For lesson 5, we are going to work on our latest formula for coordinate geometry, which is the distance formula. Now we're going to start to discover something about the distance formula that kind of makes it, I would say, I don't want to use the word optional, but it shows there are a couple variations to how we use it. So graph the triangle DEF with vertices D 4, 8, E 4, 0, and F 10, 0. So D is 4, 1, 2, 3, 4, 8. There's D. E is 4, 0, and F is 10, 0. And if we go ahead and connect all these nicely, we'll get our triangle. Okay, so determine the length of DE. Now that's easy because it is a vertical line. So then what we're going to do is we're just going to count our boxes. When we count our boxes here, we should see that we have 8. Then we determine the length of EF. All right, well, EF is easy because it's horizontal. We determine the length to be 6. Okay, so those are easy. Horizontal and vertical lines, very easy from a graph. If we look at the next part, explain why DE is perpendicular to EF. So basically, why is there a right angle here? Well, remember what it means to be perpendicular. The slopes are negative reciprocals. Okay, now you might just look at it and go horizontal and vertical lines are always perpendicular, which is true. But if we want to explain it through our slopes that we talked about earlier in the unit, then we get the slope of DE is 8 over 0, or negative 8 over 0, I should say, which we really know to be undefined. And the slope of EF is 0 over 6, which is really 0, since those slopes are negative reciprocals, DE is perpendicular to EF. All right, so anytime you're talking about perpendicular on graphs, you really want to refer to their slopes being those negative reciprocals. And then the last part is, since triangle DEF is a right triangle, use the Pythagorean theorem to determine the length of DF. So if we're talking Pythagorean theorem, we're talking a squared plus b squared equals c squared. Hopefully you look at your triangle and recognize that 8 and 6 are your legs. So those are A and B, and then obviously DF is C. So we're going to be 8 squared plus 6 squared equals c squared. 8 squared is 64, 6 squared is 36. Add them together to get 100. Square root both sides, and you get that C is 10. All right. So that's one way to use it with Pythagorean theorem. And you'll see as we go to the next part here, the distance formula is kind of similar to Pythagorean theorem. All right. So we discovered that the Pythagorean theorem can be used to find the distance between 2 points in a coordinate plane. But if we were just given the coordinates of 2 points and we wanted to plot them and draw a triangle, we could still find the distance between them. Now, you could always use scrap graph paper and basically create a right triangle between 2 points. But if you don't want to do that, here's your distance formula. D equals big square root x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. All right, so I want to practice using that formula for a little while first. So find the distance between the points 2, 8 and 8, 6 in simplest radical form. So it does not matter which one is x1, y1, and which one is x2, y2. It's really up to you. So if we look at our formula just so we have it on the screen, D equals big square root x2 minus x1 squared plus y2 minus y1 squared. So D equals big square root 8 minus 2 squared plus 6 minus 8 squared. Now, you could choose to do all this work here individually inside, but if I were you, I would just put everything into the calculator except for the square root. So I'm just going to go open parentheses 8 minus 2 squared plus 6 minus 8 squared, and I get 40. So then d equals the square root of 40. We know 40 is not a perfect square, but 40 splits. Square root 4, square root 10 comes back together. We get a distance between those 2 points of 2 radical 10, or 2 square root 10. Okay, we don't have to worry about the positives and the negatives here because we're talking about distance. Distance has got to be positive. What I'd like everybody to do is just pause the video for a second and try example 2 on their own. So to start this, we'll go x1, y1, x2, y2. So d equals big square root. We will be negative 10 minus negative 5, and be careful with your signs, plus 2 minus 12 squared. All right, again, I'm going to go to my calculator. I'm definitely not going to try to deal with all these negatives just in my head. So open parentheses, negative 10 minus negative 5 squared, plus parentheses 2 minus 12 squared. That gives me 125, so square root 125. Also not a perfect square, but splits. Square root 25, square root of 5 comes back together, and I get a distance between those 2 points of 5 square root of 5. All right. In example 3, the vertices of triangle OLD are 0, 0, negative 2, 4, and 4, 1. Determine the perimeter of triangle OLD in simplest radical form. So basically what we need to do now is we kind of have to split our paper into thirds, and we have to find the distance from O to L, the distance from L to D, and the distance from O to D. So everybody take a couple minutes here and find those. I would definitely suggest simplifying them, and then we will talk about adding them together to get our perimeter. But everybody pause for a second to find those 3 distances to see if you can find the perimeter. All right, for OL will be 0, 0 will be my x1, y1, and then negative 2, 4 will be my x2 and y2. So D equals, it'll be negative 2 minus 0 squared plus 4 minus 0 squared. If I plug all of that into my calculator, I'm going to get the square root of 20, which when I split it, square root 4, square root 5, gives me a distance of 2 square root 5. As I work with LD, I'll be negative 2, 4, and 4, 1. So with the way I wrote it, it's x1, y1, x2, y2. So D equals 4 minus negative 2 squared plus 1 minus 4 squared. So if we go to our calculator, we are 4 minus negative 2 squared plus, I believe it's 1 minus 4. Yep, 1 minus 4 squared. That gives us 45. So square root 45 splits square root 9 square root 5 gives us a distance of 3 square root 5. And then for OD will be 0, 0 and 4, 1. So x1, y1, x2, y2. D equals, we are 4 minus 0 squared plus 1 minus 0 squared. Do all that in my calculator, I get square root of 17. 17 does not split, so that's just going to be carried down. So now if we want to find the perimeter, it's going to be 2 radical 5 plus 3 radical 5 plus radical 17. These first 2 square roots can combine because they have the same number underneath the radical. So the perimeter here is, and I believe it said simplest radical form, so we add the numbers out in front. 2 plus 3 is 5 radical 5, and then plus the square root of 17. Okay, so that's how we use our distance formula to find the perimeter of a shape that would be on a graph. So example 4 has 2 parts to it. So it's almost like part A and then part B. So that's why I'm going to kind of split my paper in half here. So it says isosceles triangle CAB has the coordinates of C -1, 1, A -8, -2, and B -4, -6. Use the distance formula to prove the segments CA and CB are congruent. So, simple enough. We'll do the distance formula for CA. So that's going to be -1, 1, and -8, -2. So x1, y1, x2, y2. So big square root -8 minus -1. All right, again, be really careful with your signs. Plus -2 minus 1 squared. So -8 minus -1 squared plus -2 minus 1 squared gives me 58. Now, I'm not going to simplify that because ultimately what I'm just trying to do is I'm just trying to compare that CA and CB are the same. So if I simplify them, they'd be the same. But if I don't simplify them, they should also be exactly the same. So I'm not going to worry about simplifying it since I'm just comparing them. And then CB would be -1, 1, and -4, -6. So x1, y1, x2, y2. D equals -4 minus -1 squared plus -6 minus 1 squared. Again, be really careful with your signs. So -4 minus -1 squared. Just want to make sure I put that in correctly. Yep. Plus -6 minus 1 squared. And there's my square root of 58 again. So that checks out. This is isosceles because CA and CB are congruent. So use the distance formula to determine the area of triangle CAB given that the altitude from vertex C intersects segment AB at the point 6,4 and round to the nearest tenth of a square unit. So what I want to do here is I kind of want to just show you in a little bit of a picture what this looks like. So if we were to estimate the points, C is at -1, 1, A is at -8, -2, and B is at -4, -6. All right. So that's kind of like our triangle right there. And we found out that CA is square root of 58 and CB is square root of 58. All right. So there's our isosceles triangle. So we know that our area of a triangle formula, so area is 1/2 base times height. So they told us that the altitude from C is going to drop down and intersect at that point right there. And it tells you that that point is -6, -4. Okay, so what we need to do is we need to find AB, which is our base. Now you could use the distance formula, or you could use, oh, actually, sorry, you can't use Pythagorean theorem, not a right triangle. So we need to find the distance from A to B using our distance formula. Then we need to find the distance from C to, we'll call that point D, to find our height. And then we can plug into our area formula. All right. So first things first, I'm going to find the distance from A to B to act as our base. So from A to B, -8, common -2, -4, -6. So x1, y1, x2, y2. So the distance now is D equals big square root -4 minus -8 squared plus -6 minus -2 squared. All right, again, be very careful with all the negative signs and minus signs. So -4 minus -8 squared plus -6 minus -2 squared. And I get the square root of 32. I'm not going to bother to simplify that because we're going to end up, it tells us to round, so we're going to end up putting it in our calculator anyway. So it's a little bit of overkill to round it, or excuse me, to simplify it, because then you're just kind of risking making a mistake. So then I want to find the distance from C to D, which basically forms my altitude. So C was -1, 1, and the new point that they gave us that we called D was -6, -4. So D equals big square root -6 minus -1 squared plus -4 minus 1 squared. All right, go to our calculator. -6 minus -1 squared plus -4 minus 1 squared. And that's going to give us the square root of 50. Okay, again, same rule, not going to simplify because all I'm going to end up doing here is plugging them into my formula. So now that's our base, right? So this AB was our base. This was our height. So now if we're going to find our area, we're going to be 1/2 square root 32 times square root 50. Now, if we were putting this in simplest radical form, I would worry about simplifying, but since it just wants to the nearest tenth, we're going to be alpha y equals 1/2 times the square root of 32. Make sure I get outside the radical, and then times the square root of 50. N to the nearest tenth, well, that was easy. It turns out to give you 20, and you could put 20.0. I know that's how you would really do it, but we're just going to be at an area of 20. This one works out nicely that we don't actually have a decimal. All right, so that's a little bit of a look on how we use our distance formula to solve for, we did some perimeter earlier, we showed an isosceles triangle, and this isosceles piece is going to kind of lead us into our triangle proofs that we're going to work on in the next lesson. And then we figured out how to do a little bit of area using the distance formula.